Hello math students, it's your math teacher Mr. Hargrove here, and I want to welcome you to another edition of Mr. Hargrove's math class, where today we're going to determine what the equation is. So we are in our linear relationships unit still, and today is a very important piece of that unit where you get to determine the equation from a situation, from specifically a table. This was one of my favorite units when I was in school. It really allowed me to see all the different connections that math has, and I hope you feel the same way. So we'll go ahead and jump into the learning target. Students will learn how to write the equation that matches a given table. Students will also see how table, graph, and equation are different representations of the same information. The success criteria: students will know that they are on track to reaching the learning target when they can determine the rate of change from a table, evaluate the pattern of increase or decrease in the table to determine the point where the line will cross the y-axis, understand the difference between proportional and non-proportional relationships, and write the equation that matches the table in the form of y equals mx or y equals mx plus b. Now I know that those are a lot of variables, but again, as we work through, it'll make sense. So let's start here. When we talk about linear relationships, you're going to be dealing with relationships that are either proportional or non-proportional, and it's very important that you understand the difference between the two. It will really help you. So we'll start with proportional relationships. Proportional relationships are characterized by the following. When you're dealing with linear relationships, you're talking specifically about a line that will be graphed. So we are going to be dealing with graphs. And when you're dealing with proportional relationships, the line of the graph will pass through 0, 0. Also, the equation of the line is in the form of y equals mx. So this is what your graph will look like. And you should note that this line passes right here through this critical point, which is 0, 0. That's that point right there, and this line just makes it there where it passes through. Now, I talked about here where your equation is in the form y equals mx. Well, just to make up one, that would be like y equals 2x. That would be the equation that matches this graph, and it's not really the one that matches. I just made that up on the spot, but it would look like this. It would be in the form y equals mx, where your job is to figure out what m is. What is m? And the cool thing about this is you learned how to figure out m in our previous lesson, because m, that's simply the rate of change, which we already know how to find that. So that's the cool thing about proportional relationships. The critical thing you need to know is that it goes through 0, 0, and the equation will look like this. It'll be in that form, where this represents your rate of change. Now let's talk about non-proportional. With non-proportional relationships, they're characterized by the following. The graph will not pass through 0, 0, and the equation of the line is now in the form y equals mx plus b. So you'll notice that there's an addition, and it's this part right here. And we're going to talk about what all this represents, but this is still, m is still the rate of change, and we'll talk about what that b is, okay? But what that b is essentially saying is your line no longer starts at 0, 0. Instead, it starts at this number, which in this graph is 0, 1. You'll notice this line starts at 0, 1. Well, that 1, that is going to be what the b represents. So this equation will look something like this: y equals 2x plus 1. That plus 1 is telling me where my line is going to cross the y-axis, because you know this is x and this is y-axis. Wherever your line crosses goes right here. But in this situation, if it goes through 0, 0, then there is nothing to add, because that's where it crosses at 0, 0. So again, as we work through some examples, which we're going to get to very shortly, this will all start to make more sense. Right now, I'm just kind of laying the groundwork. So when you look at this equation form, y equals mx plus b, you need to know y and x, they're already given to you. So if you think about a table like this one here, x and y, I'm just making up some numbers right now, so y'all just work with me. So let's say these are points on a graph. They already give you y, so we already know what y is, and we already know what x is in this table. The things that we need to figure out is m and b. That's going to be the most important part for your job today. M, as I mentioned, we already know how to figure that out because that's just the rate of change. You remember, to find the rate of change, you simply do the change in y over change in x. And that tells you what m is. B, your y-intercept. So this is where your line crosses the y-axis. So when x is 0, you'll notice in this table that I made up, when x is 0, y is 3. So this line crosses the y-axis at 0, 3. So that means that 3 would be my y-intercept, or the b. But again, we're going to jump into some examples. You will see what this looks like. It may not all make sense right now, but my goal is for it to make sense to you by the end of the lesson. So let's look at this example. Example 1, they've given us a table, and that table in the X column represents number of books, and the Y represents the price of the books. Table is partially filled in, it's missing some sections, but it's given us enough information to answer some of these questions. So the first thing that it wants us to do is find the rate of change for any number of books in the table using the form change in y over change in x, and you'll notice they put here m is rate of change. So moving forward, m is rate of change. So to find the rate of change, I'm going to do change in y over change in x. Let's figure out what y and x are changing by. So to go from 3 to 6, that's plus 3. From 6 to 9, plus 3. From 9 to 12, plus 3. And then from 12 to 21, that's plus 9. And now look on this side. To go from 1 to 2, plus 1. Plus 1, plus 1. From 4 to 7, that's plus 3. So now let's figure out the rate of change. It is change in y over change in x. So I'm going to put 3 over 1, and it's 3 over 1 all the way across until I get here, 9 over 3. But what you should notice is 3 over 1 and 9 over 3, they both equal 3. So why did it jump over here to 9? Well, it did that because of what x did. You'll notice they skipped 5 and 6, so they jumped to 7, so that's why there's a bigger change. But they all equal 3. So my rate of change here is 3. At what point will the line cross the y-axis? Well, to figure that out, I need to figure out when x is 0, what is y? And this is where you look at the pattern of increase or decrease. Here I notice that it's going up by 3 every time. So that means if I go backwards, it's going down by 3. 12 to 9 is minus 3. 9 to 6, minus 3. So if 6 to 3 is minus 3, then what number goes there? If the pattern continues, the only one that would make sense is 0. So at what point will this line cross the y-axis? It will cross at 0, 0. Is this a proportional relationship? Well, if you look back at our previous slide, we would say, yes, this is proportional. And the reason is because the line goes through 0, 0. If it went through 0, 4, then it would not be proportional, but it goes through 0, 0, so therefore it is proportional. Is this equation in the form mx, y equals mx, y equals mx plus b? It's going to be in the form of y equals mx because it is proportional. And again, on our previous slide, we talked about all proportional relationships. The equation will be in that form. So what is the equation? Well, the equation here would be y equals, if my rate of change is 3, y equals 3x. That is going to be the equation. And that's going to be the main thing you're working on today, is simply determining what the equation is. Now, there's a cool thing I can do here. It says use the graph on the right to graph the line that matches the table in the equation. I shifted it down below, so disregard that it says on the right. So here's how I would graph it. I'm looking at my x column and my y column. My x, remember, flows this way. This is my horizontal. Y is vertical. So if I wanted to graph it, that's 0, 0. And let's just say, well, this is 1, 2, 3, 4. And 4 is good enough. And then when I count upward, since this is going by 3, I can do the same thing. I can just count by 3. I'll go 3, 6, 9, 12, and we'll stop there. So at 0, 0, I will put a point. At 1, 3, I will put a point. At 2, 6, I will put a point. At 3, 9, I will put a point. And then at 4, 12, a point. And my line will not be perfect, but I'm going to draw a line that goes through those points and goes on. So the cool thing, and I mentioned that this was one of my favorite units in school, is because what we've done is from the table, we made the equation that matches the table, and we also graphed the line that matches both the equation and the table. So all of these are simply different representations of the same information, which I always thought that was real cool when I was in school. So that's what we're doing. That is what we're doing. Now we're gonna shift to another example. And again, as we work through these, you will see that it will start to make more sense to you. Let's look at this example. We're dealing with same thing, number of books and price. It says find the rate of change for any number of books in the table. So that's what I'm going to do. To find the rate of change, I'm going to do change in y over change in x. So let's figure out what y is changing by. And I see a change of +2, +2, +2, except when I get from 13 to 19, that's +6. And then if I come over here, you will notice I'm using the same row. From 1 to 2, +1. From 2 to 3, +1. 3 to 4, +1. From 4 to 7, that's +3. So my rate of change is going to be change in y is 2, change in x is 1. When I get down here, the change in y is 6, the change in x is 3, and what do you know? 2 divided by 1 and 6 divided by 3 are equal to one another. They both equal 2. So my rate of change is 2. At what point will this line cross the y-axis? Well, let's look here, see if we can see the pattern. It's increasing by 2 each time. So it means if I go backwards, it's decreasing by 2. So 13 minus 2 is 11. 11 minus 2 is 9. 9 minus 2 is 7. 7 minus 2 is 5. So this line is going to cross at 0, 5. At what point will this line cross the y-axis? It's going to cross at 0, 5. Is this a proportional relationship? That would be a big no. The reason is because proportional relationships go through 0, 0. This one goes through 0, 5. So therefore, that is the reason that this is not a proportional relationship. So this would be non-proportional. Is the equation in the form y equals mx or y equals mx plus b? Well, it's non-proportional, so it's going to be y equals mx plus b. And what's the equation? Well, I need to look at two critical things to figure out the equation. I need to look at the rate of change, and I need to look at where it crosses the y-axis. So this is what I do. my equation would be y equals, my rate of change is 2x plus, what is the b? The b is going to be the number when x is 0. So that 5, I'm just going to slap it right there. Y equals 2x plus 5. That is the equation for this line. And when I graph it, I'm going to do the same thing. That's 0. We'll say this is 1, 2, 3, 4. And then since this is counting odds mostly, primarily, I can just do that. I can just make it count odd numbers. So we can say that this is 1, 3, 5, 7, 9, 11. We just make it count odds like that. And when we graph this one, the first point is 0, 5. So 0, 5 is right there. So you'll see it's not going to pass through 0, 0. At 1, 7. All I'm doing is reading the coordinates off the table. At 2, I'm at 9. At 3, I'm at 11. And then at 4, I'm at 13. So this line will look like this. So you will see, because it is not proportional, it does not go through 0, 0, and it goes through 0, 5 instead. And again, you see 3 methods of representing the same information. Y equals 2x plus 5. This is the graph that matches it. That is the table that matches it. So again, you got 3 different ways of expressing the same information. All right. Let's move to another example. And this time we'll just look at just a table only, and we'll answer these questions. So we have a table. It says number of days and the cost to rent a paddle boat. So this is going to be my x, and this is my y. What is the rate of change? Well, let's figure it out. Let's figure out what it's changing by. From 50 to 100, that's plus 50. From 100 to 50, plus 50. From 150 to 200, that is plus 50. And then from 200 to 350, well, that's plus 150. And now let's do the same thing over here. We have x is going up by 1 here, by 1, and then by 3. So now let's figure out the rate of change. Rate of change is change in y over change in x, which is going to be 50 over 1, and then we also have 150 over 3. Both of them equal 50. So my rate of change is 50. At what point will this line cross the y-axis? Let's look at the pattern. It's increasing by 50. So if I go backwards, I'm decreasing by 50. 200 minus 50, 150. 150 minus 50, 100. 100 minus 50 is 50. 50 minus 50 is 0. So this line is going to cross the y-axis at 0, 0. Is it proportional? 0, 0 means yes, I am proportional. And they said explain, that's my explanation. Crosses at 0, 0. Is it in the form y equals mx or y equals mx plus b? This is going to be y in the form of y equals mx. And what's the equation? Well, I'm simply going to take my rate of change and I'm just going to plug it right down here. Y equals 50x. That is the equation that matches that table. That is the equation. And real quick, you can prove that that's the equation this way. Y equals 50x. So that means whatever x value you plug in, you should get that y. So what this is saying, y equals 50x, is if I plug in a 1 for x, I should get a 50 as my y value. Well, let's see if you do. When you plug in a 1 for x, what's 50 times 1? Well, 50 times 1 is 50. So you see when you plug in a 1 for x, you do get a 50. Let's do the same thing, but with 4 this time. The table says that when you plug a 4 in for x, you should get a 200 as your y. Let's see. Well, what's 50 times 4? Well, if you do that math, 50 times 4 is 200. So that means if I plug in a 4, y equals 200. So that is how the equation and the table are linked. Again, I was very fascinated with that in school, and I actually still am to this day. I love seeing these types of connections being made. Just a couple more problems. Let's look at this one. Number of days and cost to rent an ATV. This is going to be your X column. This will be your Y. And what's the rate of change? Well, let's figure it out. What is Y changing by? Would it go from 175 to 250? That is an increase of 75. An increase of 75. An increase of 75. Okay? And here we have an increase of 225. Come over here, do the same thing. This is an increase of 1, an increase of 1, increase of 1, and then an increase of 3. So let's figure out the rate of change. Change in y over change in x is going to give me 75 over 1. And then when I work down lower, I get 225 over 3. And they all equal 75. So 75 is my rate of change. At what point will this line cross the y-axis? Well, if it's increasing by 75, go backwards. It's decreasing by 75. 400 minus 75 gives me that. 325 minus 75 gives me that. 250 minus 75 gives me that. So what is 175 minus 75? It's 100. So this line will cross the y-axis at 0, 100. That is the point that it will cross. Is this proportional? No. Why? Because proportional relationships go through 0, 0. This one does not go through 0, 0. Instead, it goes through 0, 100. Is the equation in the form y equals mx or y equals mx plus b? Well, it's going to be y equals mx plus b. And what's the equation? Well, y equals my rate of change with the x next to it plus 100, because this is the point where it's going to cross. It's going to cross at 0 and 100. And again, I can test this out, and I want you to test it yourself. The table says that if you plug a 4 in for x, you should get 400. Well, let's calculate that. If you plug a 4 in here, okay, and you add 100, you get 400. Okay, that would mean that 75 times 4 is going to give me 300, and 300 plus 100 is going to give me 400. So again, this is all very much connected. And I want you to test these things. Don't just trust what I say. Test it out. Test it out. Math is about proving and making sure. But again, we looked at this. If you plug in a 4, let's just do it, 75 times 4. Well, 75 times 4 is 300, and 300 plus 100, that equals 400. So y does equal 400 when you plug in a 4 for x. And I guarantee you, if you went through this table and plugged in all these numbers, you would get the y value. Very cool thing. Very cool thing. It's also a way that you can double check yourself. Double check yourself by doing that. This is the last one we'll go over. Number of songs, that's going to be X. And my Y is going to be the cost per month. What is the rate of change? I'll go faster this time because we've been practicing this. This is increasing by 2. Except when I get here, it's increasing by 6. And over here, didn't mean to do that one. This is increasing by 1, by 1, by 1, and then by 3. Change in Y over change in X is going to give me 2 over 1, which is the same thing as 6 over 3. They both equal 2. At what point will this line cross the Y-axis? Well, if it's increasing by 2, it's decreasing by 2 if I go backwards. 4 minus 2, it's going to give me 2. So this is where it's going to cross. It's going to cross at 0, 2. Is this a proportional relationship? Well, no, because it doesn't go through 0, 0. It goes through 0, 2. Is the equation in the form y equals mx or y equals mx plus b? Well, it's not proportional, so it's going to be y equals mx plus b. What's the equation? Well, y equals, my rate of change is 2, and it crosses at 0, 2. So that's my equation. And now I can prove it. This time I'll choose the 3. The table says that when I plug in a 3, I should get an 8. So let's see if that happens in this equation. When I plug in a 3 for x, do I get 8? Well, 2 times 3 is 6. 6 plus 2, what do you know? Is 8. So that's how I know it matches. Again, I absolutely loved this unit when I was in school. Absolutely loved it. So, I appreciate you for practicing this concept with me, and I just want to encourage you, continue to practice. This is a very important part of this unit, so I want to make sure that you understand it. I do want to thank you for your attention, for watching this video, and we'll see you back next time.